Parallel operation and synchronization of three-phase alternators.
Hello everyone. Today we'll be looking at the process of electrician practical session for parallel operation and synchronization of three-phase alternators.
Objectives. At the end of this exercise you shall be able to read and interpret the nameplate details of the two three-phase alternators. Synchronize the two three-phase alternators by dark lamp method and test it. Synchronize the two three-phase alternators by dark and bright lamp method and test it. Synchronize the two three-phase alternators by synchroscope method and test it. Tools Instruments. Trainees Toolkit 1 number. Moving ion voltmeter 0 to 500 volt 2 numbers. Frequency meter 45 to 55 Hz 1 number. Phase sequence indicator 1 number. Synchroscope. Equipment machines. Three-phase alternators 5 kV by 500 volt 50 Hz coupled with prime mover adjustable speed control. Rheostat 150 ohms, 1 ampere, 1 number. Materials. TPIC switch 16 ampere, 500 volt. Ion-clad double pole switch 16 ampere to 50 volt, 1 number. Ion-clad triple pole switch 16 ampere, 500 volt, 2 numbers. 100 watt 250 volt lamps, 6 numbers. Connecting wires. Task 1. Read and interpret the nameplate details of the alternators. Read and interpret the nameplate details of the three-phase alternator. Note down the details of alternators in Table 1. Task 2. Synchronize the two three-phase alternator by dark lamp method and test it. Check the phase sequence of the main bus bar line by using phase sequence indicator meter. Connect and set the arrangement of incoming alternator and outgoing alternator with prime mover coupled TPIC main switch, voltmeters and frequency meters and lamp connection in series. Keep the main switch of incoming alternator 1 in closed position after ensuring the phase sequence are correct. Keep the main switch of alternator 2 in opened position. Start and run the first alternator and build up the rated voltage. Measure the line voltage between phases, then measure the frequency of an alternator 1 and note down the readings of voltmeter and frequency meters in Table 2. Start, run and build up the rated voltage. Measure the line voltages and frequency in alternator 2 and note down the readings in Table 3. Check the condition of the two lamps. If the voltage and frequency are equal, the lamps will becomes dark and then becomes bright. If the voltage and frequency of the both alternators are not same, the lamps will flicker. Adjust the field excitation current in the alternator 2 and bring the voltage to the same value of the alternator 2. Check the condition of lamp's brightness. If the lamps are flickering still now, then the frequency may not be equal. It must be brought to same equal frequency value of alternator 1. Adjust the speed of the prime mover of alternator 2 and bring the frequency as same as in alternator 1. Now, all the lamps are bright and then become dark at a time. It indicates all the conditions are fulfilled for synchronizing. Close the main switch of alternator to when all the lamps are in dark condition. Switch on common load for both the alternators. Check the loads are shared equally by the two alternators. Get it checked with your instructor. Task 3. Synchronize the two three-phase alternators by dark and bright lamp method. Check the phase sequence of the main bus bar lines by using phase sequence indicator. Connect and set up the arrangement of the alternator 1 and alternator 2 with prime mover TPIC switch lamp connection. Two pairs of lamp are connected across two phases. In one phase, the pair of the lamps are in series with voltmeters and frequency meters. Keep the main switch of alternator 2 in opened position. Start and run the first alternator and build up the rated voltage. Measure the line voltage between phases, then measure the frequency of an alternator 1 and note down the readings of voltmeter and frequency meters in table. Note down the readings in table 4 and table 5. Look at the condition of the lamps. If the voltage and frequency are equal, then one pair of the lamp will be dark and other two pair will be bright. If the voltage and frequency of both the alternators are not same, then the lamp will flicker, not giving standstill lighting. Check the voltage and frequency are not equal. Repeat the steps of task 2 and bring the same value of voltage and frequency as in alternator 1. If all the conditions are fulfilled, then all the lamps will not flicker and one pair of the lamp will be dark and other two pair lamps will be bright at a time. Close the main switch of alternator to when the lamps are bright condition. Switch on the common load for both alternators. Check the loads are shared equally by the two alternators. Task 4. Connect two alternators in parallel by using synchroscope. Collect the instruments as shown. Connect the equipment and instruments. Start the incoming alternator, alternator 2, with low excitation. Close the bus bar switch S1. Observe the bus bar voltage V1 and incoming voltage V2. Adjust the excitation of the incoming alternator till V1 equal to V2. The voltage of incoming and exciting machine should be equal. Check the pointer in the synchroscope. Adjust the speed of the alternator. If it is indicating fast, reduce the speed of the incoming machine gradually, observing the synchroscope pointer. Adjust the speed of the incoming alternator for minimum oscillation of the synchroscope pointer. Close the synchronizing switch S2 at 0 and the steady position of the synchronizing pointer.
Now you can read and interpret the nameplate details of two three-phase alternators. Synchronize the two three-phase alternators by dark lamp method and test it. Synchronize the two three-phase alternators by bright and dark lamp method and test it. Synchronize the two three-phase alternators by synchroscope method and test it. Hope you had a clear understanding on this technical process. Thank you.